Okay, we're going to look at the test that we took on the last Friday of half term. Now this test highlighted some problems that we're having as a class, some to do with positive negative numbers, some to do with just general numeracy accuracy. So we'll start with question 1 and 2. Now one of the difficulties we're having is understanding the difference between addition, subtraction and multiplication. So this question is an addition question, but many students mistook it for, or made some mistakes because they were misinterpreting the rules for multiplication. I'll explain that as I go through the problem. So this question, minus 3.2 plus minus 4.1, is an addition question, which means we should think about this on a number line. Okay, we did this with that game where we had hot air balloons and we were adding puffs of hot air, subtracting puffs of hot air, adding sandbags, or taking away sandbags. So if we think about this on the number line, we can think about starting at minus 3.2. Adding minus 4.1 is adding 4.1 sandbags. So we would go more negative than we were before. So if we add minus 1, we get to there, add minus 2, we get to there, add minus 3, we're here, add minus 4, here, then add a little bit more, minus 4.1. Okay, so moving down the number line. The correct answer for this question was minus 7.3. Lots of people mistakenly wrote the answer 7.3. Okay. One of the reasons people wrote the answer 7.3 is because they saw two minus signs in the question and they incorrectly deduced that minus and minus makes a plus. This is only true when you have two things multiplied together. This doesn't make sense in the context of this question. You can see by the logic that I've made that we must end up at minus 7.3. There is no way we could end up at plus 7.3. It wouldn't make sense. You could use the plus minus rule in this question. If we look at these two symbols, we have plus minus next to each other, so plus minus becomes a minus. So we could change the question to be minus 3.2 minus 4.1. This is the same question. We're at minus 3.2 and then we move to the left by 4.1, ending up at minus 7.3. Okay. Let's look at the next question. Maybe if you've got the second question wrong, then you should redo the question having looked at this, pause the video and see if you can use the same logic to answer that question. So we could, on this question, also draw a number line. If we think about what's going on in this question, we're at minus 6.4 and we're adding 3.1, which means on my number line we are moving to the right because we're going in a positive direction. We can add 1, add 2, add 3, add 0.1, and then we will end up at this number here, minus 3.3. Some people incorrectly thought that this was the same as the previous question from the other test and wrote an answer of minus 9.5 without really thinking about the question. You must think about the question in its context. Question 3. Most people did this question correctly. I think a couple of people made a mistake, but you should have written minus 9 times minus 9 equals 81. We've got a minus and a minus multiplied together, so we get a positive answer. Now there's a good way to think about minus times a minus that I've introduced to people I've taught in the past, but I haven't introduced to our class yet. We could think of the minus sign, like minus 9, as just being minus 1 times. So I could rewrite minus as minus 1 times 9. Notice how I've written minus and minus 1 times as being the same thing. This sort of makes sense because minus 1 times 9 is the same as minus 9. If we understand this, then we could rewrite the question minus 9 times minus 9 as the following. Minus 1 times 9 times minus 1 times 9. I haven't changed the question, I've just changed those minus signs for minus 1 times. Now, we know that we can put multiplication in any order we like, because 2 times 3 is the same as 3 times 2. So I could rewrite this as minus 1 times minus 1 times 9 times 9. All I've done there is change the order of the multiplication but it doesn't matter the order in which we do multiplication. So, we now have an easy way to solve this question. We can think about the minus 1 times the minus 1, and we know minus 1 times minus 1 is 1. We can also do the 9 times the 9, which is 81. So we end up with the question 1 times 9, 1 times 81, which is 81. Let's just go back. Okay, so that could be another way to think about the same question and why those minus signs will make a positive answer. Excellent. Let's move on. Okay, so we're going to use the same logic we did in question 3 now. So we're going to change minus 3, and maybe you could do this yourself by pausing the video, using the same logic I did in question 3. How can you use that logic and apply it to question 4? Well, we could change minus 3 to be minus 1 times 3. We could change minus 8 to be minus 1 times 8. And rearranging the order of multiplication, we could write this as minus 1 times minus 1 times 3 times 8. We know that minus 1 times minus 1 is 1, and we know that 3 times 8 is 24, so we get an answer of 1 times 24, which is 24. Okay. In this way, we don't need to remember that minus times minus is plus. We have to know that minus 1 times minus 1 is 1, but I think that's fairly straightforward, I would hope. But this just uses logic rather than memory, which I quite like. Next, if we look at B, we can use the same logic. Maybe you should pause the video and try using that logic on this question. So, minus 5 times 8, we could write as minus 1 times 5 times 8. Okay. So we keep the minus 1 the same, and 5 times 8 we know is 40. And minus 1 times 40, well, that's going to be minus 40. So the answer to this question is minus 40. Looking at question 5, we're going to use exactly the same logic as well to answer this question. So we can rewrite minus 2.5 as minus 1 times 2.5. We're going to times that by something, and that's equal to minus 1 times 15. Okay, so what we're really asking in this question, we don't have to remember anymore that a minus times a positive makes a negative. We can think about, well, we need these two things, 2.5 to times something, to be the same as 15. Because there's 1 minus 1 on the left-hand side, 1 minus 1 on the right-hand side, so we just need 2.5 times something to be 15. 2.5 times 2 we know is 5, so it must be true that 2.5 times 6 is 15. So the answer to the question is 6. Moving on. Okay. This was upsetting in most cases, and I was fairly disappointed with how we answered this question. Firstly, no one that I saw wrote the following. The area of a parallelogram is equal to the base times by the height. If you'd written this, you might have understood more easily which lengths to use. This length 6 we could consider as the base, and this length 8 we could consider as the height. It's really a kind of a parallelogram just on its side, and that seemed to confuse people. That length 10 there is not the height of the parallelogram, it's a red herring. Some people wrote red herring, but they circled 8 rather than 10 as their red herring. So, since we know the base and we know the height, and we know that the area of a parallelogram is base times height, now if you're not sure why it's base times height, you should look at the notes in your exercise book or in your textbook. I won't go through that in this video, but the area being base times height, we just get 6 times 8, which is 48. Okay, question number, I believe, let me just check. Okay, so we're now on question, it will probably appear as question 7 on your book, on your test. So, this question, no one I saw recognised this shape as being a trapezium. Most people split it into a square and a triangle, which I will do later, but to start with, the shape is a trapezium. So we can use the formula for area of a trapezium. It's half the sum of the parallel sides times the height between them. So the sum of the parallel sides, in the formula, you get a plus b, and you half that. So it's a half of the sum of the parallel sides times by the height. Half a plus b times by the height. The parallel sides are the 5 and the 17. These are the parallel sides because they are parallel. The height between them is this length 5. That 13 is irrelevant. Okay, so we can substitute the numbers into the formula. So we get a half times 5 plus 17 times by the height between them, which is 5. We'll follow the rules of BIDMAS. So we do this stuff in the brackets first. A half times 22 times 5. Now, it doesn't matter which order we do the multiplication in. So we could do a half times 22, which is 11, then times 5, which is 55. Or alternatively, we could do a half times by, we could do the 22 times 5 first to give us 110. Then we half this to get 55. So the answer was 55. Let's look now at what happens if you do correctly split it into a square and a triangle. Everyone pretty much said that the area of the square was 25, 5 times 5. Very few people realised that the triangle had a height of 5 and a base. Well, what's the base? Think about it now. What is the base? The base is clearly not 17. 17 is the length of the whole of the bottom side. The length of the base is going to be 17 minus the length of the square, which is 5. So you should get a base length of 12. We know that the area of a triangle is a half base times the height. Incidentally, this 13, which lots of people used in their formula for area of triangle, is just a red herring. It doesn't mean anything for the area of the triangle. Okay, so to find the area, total area, we're going to add the 25 to a half of the base times the height. 5 times 12 divided by 2, or a half of 5 times 12. 5 times 12 is 60, times by half is 30. So 25 plus 30 is 55. Now, of course, we should get the same answer for either method, and we do. Only a few people got this question correctly, so you need to really think carefully about these area questions, which lengths you need and which lengths you don't. Also, not knowing the formulae is a criminal offence. You must know these formulae. Okay, let's move on. Okay, a few people did this question really well. Some people made a lucky guess. Some people had no idea. So, let's look at this question. We have 4 rectangles that are 10 by 6, 2 squares, which are 10 by 10, and we stick these to make a cuboid. So we're going to look at the net first, and one answer was brilliant. They drew the net, and the net looked like the following. They had 4 10 by 6, and then they had 2 10 by 10. Now what they did is they imagined folding this up to make a cuboid. When you make a cuboid like this, you're going to have a shape that looks like this. Okay? So let's label the lengths of this cuboid. We have the 6 centimeter width, the 10 centimeter depth, and the 10 centimeter height. Now the question says work out the volume of the cuboid. So many people just misread this question and tried to work out a surface area. Some people had no idea what you were doing, but it wasn't working out the volume of a cuboid. The volume of a cuboid is length times width times depth. So we know the length is 10, the width is 6, and the depth is 10. So we get 10 times 6 times 10, which is 600. You can see that my working is really clear. Have a look at your own working. Can you read your own working? If you can't read your own working, how do you expect me to read your own working? Sometimes in an exam, what I'm going to ask you to do in future is have some rough paper next to you and to use the rough paper for your jottings, and then to make a solution that looks as clear as the one I've written. Okay, let's move on. So, this question asks for a volume of the surface area of a cube given its volume. Well, let's draw this cube. We know that in a cube all the lengths are the same. Okay, let's label the length to be x. So the depth is x, the width is x, and the height or the length is also x. The volume of a cuboid, therefore, is going to be x times x times x. And the answer to x times x times x in the question is 27. Also notice how writing x's with the curly lines makes it easy to differentiate between the times sign and the x sign. Okay, so x times x times x is 27. We need to think about what number, when you times it by itself 3 times, gets an answer of 27. Well, we know that 3 times 3 times 3 is 27, so this means that x is 3. So the length of each side of this cube is 3 centimeters. We now need to work out the surface area. Each surface is a square. Each square is 3 by 3. So the area of each square is 9 centimeters squared. There are 6 squares on the surface of this cube. If you're not sure about that, get out Leo's Rubik's Cube and check yourself. There are definitely 6 squares on the surface. So it's 9 times 6, which is 54. Let's move on. This question was pretty much done very well. 1 or 2 people just made a mistake in the last question, I believe, doing times 100 instead of divide by 100. So 0.4 times 100, we're going to move the decimal point 2 places to get an answer of 40. 0.07 divided by 10, we're going to move the decimal to the left 1 place to get 0.007. 8.9 times 1,000, move the decimal place 3 places to the right to get 8,900. 0.69 divided by 100, move the decimal place 2 places to the left to get 0.0069. Question 10 was almost done correctly across the board. If you made a mistake, you just didn't carry a 1 or something like that. So you should get an answer of 43.2 for that question. Check your working is correct. If not, just redo it. Next. This was such a shame. The people who unfortunately got this wrong, they sort of just made up how to do multiplication. The most common error was to do 0.2 times 0.7 and then to do 8 times 4 and add it together. But that can't be correct, and I'll show you why. So one way to do this question, or the only way that I would suggest doing this question, is to consider changing 4.7 to 47 and change 8.2 to be 82. We've times by 10 and times by 10, so we know that we're going to divide the final answer by 100. We can also think about the fact that there are 2 decimal places in the question, so there will be 2 decimal places in the answer. Next, we're going to do 47 times 82 rather. So notice how I'm going to do 2 times 7 to get 14, but I'm also going to do the 2 times the 40 to get 80 and then carry the 1 to get 90. So you don't just do the 2 times the 7 and then the 8 times the 4. You have to do the 2 times the 7, the 2 times the 40, and then do the 8 times the 7 and the 80 times the 7 and the 80 times the 40. Okay? So that's why you can't just do 0.2 times 0.7 and 4 times 8. Okay. Also, if you did just do 0.2 times 0.7, you probably would have written an answer of 1.4. 0.2 times by 0.7, 2 decimal places in the question, 2 decimal places in the answer, so 0.2 times 0.7 is actually 0.14. Anyway, so back to this. 2 times 7 is 14, carry the 1. 2 times 4 is 8, add the 1, gives you the 9. Okay, 80 times 7, so we need that 0. 8 times 7 is 56, carry the 5. 8 times 4 is 32, add the 5, gives you 37. Find out the answer by adding the columns. 9 plus 6 is 15, 7 plus the 1 is 8, 3 on its own is 3. So we need to now divide the answer by 100. There are 2 decimal places in the question, 2 decimal places in the answer. 38.54 is the final answer. Question 12, or not question 12, it probably appears something else on your exam. So let's look here. 108.15 to 1 decimal place. We don't need to do this, but just for the purposes of this question, I put a dotted line here after the first decimal place. 5 rounds up, so we get 108.2. 9.47 to 1 significant figure. This is what the first significant figure, the second significant figure, and the third significant figure. So the final answer should be, well, we could draw a dotted line. 4 rounds down, so we get 9 as our final answer. 38 to 1 significant figure. 3 is the first, 8 is the second. So we draw a dotted line. 8 rounds up, so we get an answer of 40. If you got this question wrong, it's probably because you wrote 4, and 4 is a completely different number to 38. 40 is much closer to 38 than 4 is, so it makes sense that 1 significant figure would put the answer to be 40 rather than 4. Okay, moving on. I won't go through this question in too much detail. If you did this question wrong, it's probably because you didn't carry a 1 somewhere. So when you add these digits up, add these prices up, you should get 41.19. If you didn't check your maths, when you do 50 subtract 41.19, you get £8.81. Right, question 15. Estimate by rounding to 1 significant figure. So many people just didn't round their question to 1 significant figure. They did 62 divided by 6, rather than what I wanted them to do, which was 60 divided by 6, because it says round to 1 significant figure. Not round to 2, 62 is 2 significant figures, round to 1 significant figure. 62.1 rounded to 1 significant figure is 60. 5.9 rounded to 1 significant figure is 6. 60 divided by 6 is 10. Your answer should have been 10. So if you got this question wrong, it's probably because you didn't read the question properly or didn't understand what the question meant. So when it said by rounding to 1 significant figure, it meant rounding the question, the numbers in the question to 1 significant figure to make the question easier to estimate. If you were trying to faff about with 5.9 into 62.1 using the bus-stop method, you know you've done something wrong. Okay, let's look at 16. So people who attempted the correct method and got it wrong, that's unlucky. If you did attempt the correct method and got it wrong, I'll point out where the mistakes might have come from. If you didn't use the correct method and got the answer wrong, then shame on you. Okay, 3 divided by 0.06. This is a division question. We don't like the division symbol. We prefer fractions. So let's write it as a fraction. Now, if you got this question wrong, just check that you did 3 over 0.06, which is 3 divided by 0.06, and not 0.06 over 3, which would have been the wrong way round. If you got to this stage, chances are you got the question correct. You would then make an equivalent fraction, so times top and bottom by 100 to get 300 over 6. And then 300 divided by 6 is fairly straightforward, it's 50. Now notice how I don't need to change the answer, okay? The reason I don't need to change the answer from 50 to be 0.5 is because this fraction, 300 over 6, is an equivalent fraction, which means it's exactly the same as the first question. It's equivalent, equal to. Notice the equal signs are used correctly. So I can say that everything is equal to everything else, which means the answer must be 50. That's why we use equal signs. Okay, question B. This naturally caused more problems for people because you've got a strange division. It's not really a division. Okay? We're going to look at the fraction here. So change it to a fraction. Now, if you got this wrong again, it's probably because you did 20 over 0.8 rather than what you should have done, which is 0.8 over 20. it now makes sense to times top and bottom by 10 to get 8 over 200. This is 8 divided by 200, not 200 divided by 8. Now technically, this is your final answer. 8 over 200 is an absolutely fine answer. We probably want to simplify this because 8 over 200 can be simplified. There are two ways to simplify this. One, we could write it as a decimal. We don't really like 8 over 200, so let's change it to 4 over 100 by dividing top and bottom by 2. 4 over 100 is 4 hundredths, which is just 0.04. We could also write it as an even simpler fraction by dividing top and bottom by 4 to get 1 over 25. 1 over 25 is a brilliant answer. This is a simplified fraction. You can't get more simple than 1 over 25. Why won't we just write the answer as 1 over 25? Why are we obsessed with decimals? Okay, 1 over 25 is a perfect, valid answer. Okay? I think I'll leave that question there. Next. The final question, if you got this wrong, is because you, for some reason, don't seem to understand the difference between multiplication and division. So many people decided to write 400 over 0.01. That over symbol, the fraction symbol, doesn't mean multiplication, it means division. So if you got this question wrong, you need to ask yourself the question, do you understand division? Okay? So, 400 times 0.01, well, we could change the question slightly and then adapt our answer accordingly. Some people did something where they did, say, 400 times by 1, which is 400, and then divide the answer by 100. That makes sense. You might also have divided 400 by 100, and then times 0.01 by 100. This way I haven't really changed the question. I've divided the question by 100 and timesed it by 100. So I've timesed it by 1 essentially. I've done nothing. So it should be, so you get 4 times 1, which is 4. If you'd written 400 over 0.01, then you really shouldn't have, because this is not a division question. That over symbol is a fraction and also means division. Okay? So that's the end of the video. It's a bit longer than last time, but I tried to go into more depth with my explanations. Right, I'll stop there. Thank you very much for watching.